we're going to deal with two variable inequalities today, instead of the one like I just showed you. So for example, let's say you had this problem. X plus y is less than or equal to 9. Let's just start listing some answers to this. What are some possible things x and y can be to make this true? Just shout them out. What are some of them? 1 and 5 would work, right? That'd make it 6. What else? 2 and 2 would work, right? These would make this true, right? What else? 1 and 1 would make it true. 3 and 2 would make it true. 5 and 4 would make it true. Right? We could go on forever, right? We could just keep going, and there would be an infinite amount of things that would make this true, right? We could start getting into negative numbers. We could start getting into decimals and fractions. We could get all the way up to 9. You know, sometimes if y was 5, this could be 1. But if this was 5 and this was 5, it wouldn't work, right? It'd be greater than 9. So the problem we run into here is we can't put these answers on a number line because it depends on what x is, what y can be, and vice versa. So we have to come up with a better way to put all these answers than a number line, which luckily there is one, and that's what we're going to talk about today. So we're going to solve two variable inequalities, but we're going to express our answers not as a number line, but as a graph instead. And then we're going to be able to show what all of the answers are to this problem without listing them, because that would be impossible. It goes on forever, right? So how we do that is going to be on a graph. And remember, when we graph stuff, what type of form do we want it in? When we graphed equations, what was that form called that we wanted it in? Close. Standard form we use, but not the graphing one. Remember? Some people are saying they're just not confident enough. Point slope form would work, but there's even a better one for when we graph. Slope intercept form, right? Remember, slope intercept form is y equals mx plus b, right? And the number without the variable is our y-intercept. The number in front of the x is our slope, right? Luckily, we can use the exact same thing for inequalities. Just instead of an equal sign here, there'll be a greater than, less than, greater than, equal to, less than or equal to. So we're going to graph these types of equations today. So I have a note sheet for you, since you don't have graph paper, of the ones we're going to use. And I'm going to show you how we can put all our answers to these inequalities on this graph. This first one on your note sheet, this is a two-variable inequality, right? There's an x, there's a y. It's an inequality. It's not an equal sign, okay? So what we want to do is we want to graph this first, okay? And it's already in slope-intercept form, so we can go ahead and start graphing. What's my y-intercept here? Positive 4, right? It's always a number without the variable. So I'm going to go to the y-axis at 4. 1, 2, 3, 4. And I'm going to put, it's going to go through that point. Right. And my slope then is obviously what? Negative 3. And remember, slope is always rise over run. The top number tells you up or down. The bottom number tells you left or right. So I'm going to go down, 1, 2, 3. I'm going to go to the right 1. And I'm going to do this a couple times just to get a real accurate line. And we're going to connect those. And remember, we always put arrows on the end because it goes on forever. Okay. Now, what this is called a boundary line. This means all the answers to this inequality lie on either this side of the boundary line or they lie on this side of the boundary line. And we're going to figure out which side that all the answers are on. And then later we'll talk about the boundary line itself. So what we want to do is we want to figure out, are all the x's and y's that make this true, are they over here or are they over here? This is my boundary line. They're going to be on one side or the other of this boundary line. Okay? And so what we're going to do is test a point. We're just going to pick an xy coordinate and we're going to test it out in this inequality. And if it's true, that means all the answers are on that side of the line. If it's false, they're on the other side. So what we're going to do is pick a test point. What would be an easy coordinate point to pick, to plug in here to test this? 2, 2 would be pretty easy, right? If you plug in 2, 2, that's this point. You could plug in 2 for x, 2 for y, and see if it's true. That would be an easy one. I'm thinking even easier than that. 1, 1 wouldn't be bad. It would be easy also. It's on my boundary line though, so I'd rather pick a different one. 0, 0 is right here, right? When you work with 0, it's really easy because anything times 0 is 0. So let's test out the point 0, 0. If I plug in 0 for y and 0 for x, I want to see if this makes this inequality true. So you can just do this, work off to the side there kind of on your graph. Well, negative 3 times 0 is 0. And 0 plus 4 is 4. So is this a true inequality? Is 0 greater than or equal to 4? No, right? That is false. That means that point is not part of my solutions. It's not part of the answers here. So since this is my boundary line, that means all the answers aren't on this side. It means all the answers are on this side of the boundary line. And how we represent that is we just lightly with our pencil, we're going to shade the other side of the boundary line to show that all the answers are on this side. Okay? And you don't have to be real exact. I mean, you don't have to get every square inch. You just kind of want to briefly shade the other side. And that shows me all the answers are from this boundary line that way. So what's nice about that is now I can just give you a coordinate and you can pretty much instantly tell me, is it part of the solution or not? Does it make this true or not? For example, if I gave you the point 5, 1, without plugging it in, would that make this true? Yeah, it would, right? Because 5, 1 would be 1, 2, 3, 4, 5. It'd be this point right here. It's part of my solution region. Okay. What about the point 0, 10? Would it make this true? Yeah, because it would be up here. It'd be part of my solution region, right? What about the point -3, -1? No, because that would be right here. That's not part of my solution region, right? And we could check all these if we plug them in. But once you have it graphed, it's really easy to tell what's part of your solution and what's not. So this is a good way to list out all the possible answers this could have without listing them, because that would be impossible. What about the point 100, 100? Would that make this true? Yes. Yeah, because that'd be way out here to the right and way up here to the top. It'd be way up here in this corner if we had a bigger graph, and it would be part of the solution. It'd be part of the shaded region. So this is going to be how we express answers to two variable inequalities, with these boundary lines and with the shaded area. Now, what if I asked for a point that's right on the boundary line? For example, I want to know is 0, 4 part of my solution? What do you think? Because that's right on the boundary line. We're talking about, is this going to be part of our solution? It's right on the boundary line. Let's test it out, right? Let's plug in x is 0, y is 4. So I plug in 4 for y and 0 for x. That's going to give me 4 greater than or equal to 0 plus 4, which 4 greater than or equal to 4, which is true, right? So it's part of my answer, but it's kind of just barely, right? Because it's or equal to. So it is part of my answer. So points on this boundary line do make this true. They are included, but just barely. Kind of like when you did the closed circle on the number line, that number was included, but nothing to the other side. Same thing with the boundary line. Okay. Any questions with that one to start with? So the next one here, is this in slope-intercept form? Yeah, y is by itself, right? So I'm going to go to my y-intercept of -5. It's going to be right there. I'm going to use my slope, which is positive 3/5. So from there, I'm going to go up 3 to the right 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay. It'll be off the graph. And I'm going to draw, there's my boundary line. Again, that means all the solutions to this inequality are either on this side of the boundary line or they're on this side. And I'm going to test a point to figure out which side they're on. And I still think the easiest point to test would be 0, 0. Again, you could test any point you wanted to. The problem was if you tested a different point other than 0, 0, you'd have to take 3/5 times whatever you plug in for x. Then you probably have to get common denominators to subtract from 5 and so on, right? So 0, 0 is just going to make it a little bit faster. So let's plug in 0 for y and 0 for x. Well, 3/5 times 0, I know is 0. 0 minus 5 is -5. Is that a true statement? Is 0 less than or equal to -5? No, right? It's actually greater than, right? Would you rather have $0 or be in debt 5? You'd rather have 0, right? It's greater. So 0 less than or equal to -5 is false. That is not true. So that means that is not part of my solution region. So I don't want to shade over that because I only want to shade over the side where all the answers are. So that means instead of shading on this side of the boundary line, it would be on this side. So we're going to kind of just lightly shade that side because my test point was false. If I picked any point on this side, it would be false. I just know 0, 0 is easy to work with. Now if I picked any point In the shaded area, it should be true. Okay. So again, just looking at the graph, what if I asked for the point 100, negative 100? Without doing the math, is that going to be a solution? Yeah, it would be, right? Because it would be way over here to the right and way down. Okay. What about the point 0, negative 5? Is it a solution to this? X is 0, y is negative 5. Well, that's this point right here. It's on the boundary line. It would be. It would be. Because if you plug in 0 for x, that becomes 0. You plug in negative 5 there. It'd say negative 5 equals negative 5. Which barely is part of the solution, but it would work. Now, sometimes your boundary line may not contain the solution. And we're going to look at an example of that in just a second and how to tell the difference. We good there? Negative 5, right? 1, 2, 3, 4, 5. What's my slope? Negative 1, so negative 1 over 1. So that means from that point I'll go down 1 to the right one. And since I'm running out of room that way, I'll go the opposite way too. I'll go up 1 and back 1, so I'll put several points. Now on this one, before we draw our line, I want to test out a point on the boundary line. Let's test out this point, which is 0, negative 5, right? You don't have to do this here, but I just want to show you what this would look like. If you test out that point and plug in negative 5 for y, 0 for x, you would get this. Is this a true statement? Negative 5 greater than negative 5? No. So that's a problem, because in the previous questions, we saw that our boundary line was true, any point on that boundary line. And in this problem, we saw that our boundary line has a point that's false. It's not true. What's the major difference between the previous two problems we just did and this one? Yeah, Sam?
The last ones were like greater than, equal to.
Exactly. The last ones had the or equal to, right? Because if this would have an or equal to, I'd be good. It would work. But this one doesn't. So we need a way to differentiate between drawing a graph where the boundary line is part of the answer and drawing a graph where the boundary line is not part of the answer. And the way we do that, when it's just greater than or just less than, is instead of making it a solid line, we do a dashed line. And what that dashed line tells me is that any point that's on that dashed line is not part of the answer. It's kind of like the open circle we did on the number line, right? Remember when you didn't fill in the circle? That means that number was not included, but every number on one side or the other is. It's the same thing in this. When it's just greater than or just less than, it's going to be a dashed line, because that means every point on that line is not included. That's a very important difference between the two. Everything else will be the same. It's still a boundary line, and all the answers are either on this side or this side. We just have to figure out which side they're on. And by doing that, I'll test 0, 0 again. Now, what do we think would be the only time when 0, 0 would be a bad point to test, probably? Yeah, if it's on the boundary line. You know, if I had this line, I wouldn't test 0, 0 because it goes through 0, 0. As long as 0, 0 is on one side or the other, I would pick that. So if we plug in 0 for y, 0 for x, again, it says negative x, but there's no such thing as negative 0, so I just plug in 0. It says 0 greater than negative 5. True or false? True. All right, that's true. That means 0, 0 needs to be in my solution region. Right? So I need to shade over that side, so it's going to look like that. Every point in that solution region, or in that region, would be a solution to this inequality. Now, a good question would be, why the heck are we even doing this? Why do we need to know what would make this true? Because eventually, a little bit in this math class maybe, but in future math classes, you'll start getting problems where it says, okay, if X is your total number of supplies for something and Y is your total cost, how many can you sell this many of whatever you're selling and make this much money? And you would look at a graph and say, yeah, that would work or not, and so on. It gets kind of confusing, but we just need to practice the skill to start with. Okay. So any point in this solution area would make this true. Okay, is this in slope-intercept form? Yeah, it is. There just happens to not be an x here. And really, we could do this one on a number line, right? Because there's just one variable. But we're not practicing that today. So you could do this one on a number line pretty easily. You'd put open circle negative 4, it'd be everything to the right, right? But since we're working with two variables, let's assume this is a two variable problem and there just happens not to be an x. So let's graph this. Just like if there was an equal sign there, let's graph it. Negative 4 would be my y-intercept. And since there's no x, it's like there's a 0x. What type of line has 0x or 0 slope? Horizontal, right? Horizontal is a 0 slope. Vertical, up and down, has what type of slope? It's impossible to walk up a wall, impossible to ride the roller coaster, remember? Undefined? Okay. So, am I going to put a dashed line or a solid line through this point? Dashed because it's just greater than. That means every point on this line is not part of my answer. Right? Because if you plug in this point, 0, negative 4, if you plug in negative 4 for y, it's not true. So I want to make sure my boundary line, these numbers are not included, because all of these have y negative 4. So let's figure out which side to shade. Let's test 0, 0. Plug in 0 for x and 0 for y, where there's only one place to plug it in. 0 greater than negative 4. True or false? True. So I want to make sure I shade over that side, so my solution region would be that one. Everything above it. Which makes sense, right? All the y's bigger than negative 4 or go above this, right? They're all here. All the y's less than negative 4 are below that. Negative 5, negative 6, and so on. So on the first one, negative 5 is my y-intercept. I'll go to negative 5 on the y-axis. Slope is positive 2, or 2 over 1, so up 2 to the right 1. I'll put several points. Are you going to have a dashed boundary line or a solid boundary line here? Dashed. One way people remember it too, if you just forget, or equal to's have a solid line underneath, right? So they're solid lines. If it's just greater than or just less than, it doesn't, so it's a dashed line. Because every point on that line is not part of your solution. So it's the same thing as an open circle on the number line. So I can test out my test point 0, 0. 0 greater than 2 times 0 minus 5. 2 times 0 is 0. 0 minus 5 is negative 5. Is 0 greater than negative 5? Yeah. Yep, true. So I want to make sure to cover that in my solution region so it would look like that. On number 5. Slope up 7. The right 4. Will be solid or dashed boundary line. Solid, because that means every point's part of your solution. So then I want to figure out which side are all my solutions. So let's test our point. 7/4 times 0 will be 0. 0 plus 2 is 2. True or false? False, right? I don't want that. That's not part of my answer. So I don't want to shade on this side. Instead, I want to shade on this side. Now, one other way to remember it, and we're going to do an activity on the computers here in just a second to look at this. If it's greater than, it's always going to be above the line, right? Because all the greater than numbers are up here in this way. So if it's greater than, it's always above the line. If it's less than, it should be below the line. So you might want to look at your graphs and make sure that's true. But the reason it's good to know how to do a test point, though, is because sometimes maybe if the line's close to vertical, it's hard to tell what's above and what's below. Some people mix that up. But also just to know any point in this region makes it true. So that's why I've been testing a point. But if it's greater than, it should be above the line. Less than would be below the line.